We have three main types of quadratic functions we look at. Obviously, they're all quadratic functions, but when I'm talking about the types, I'm talking about like the forms, the way that the equation looks. So I'm going to give you a brief overview in this video, and then I'm going to actually title each an example of each of the types separately, so that way if you are better with one type, maybe you don't need to watch the video. So the first type is standard form. And remember, as I'm taking notes on here, you should be writing these down somewhere as well. If you need to pause the video to catch up with writing, that's completely fine. So standard form is f of x equals ax squared plus bx plus c. Sometimes this is also called expanded form. You might see it called that as well. In this case, a can't be 0, but b could be 0 or c could be 0. And once b or c becomes 0, the function becomes easier to work with in different situations. And the important things are you need to be able to find different pieces of information. So obviously we are talking about quadratics, so it looks something like this or something like this. And a tells us some important information. A is our vertical stretch factor. So it tells us whether the function is fatter or skinnier. So if a is greater than 1, it is stretched, making the entire function, the graph of the function, skinnier. If a is less than 1, but greater than 0, and I'm going to make this the absolute value of a. Remember, absolute value bars just make something positive. We're really just talking about the absolute value of a, because if a is negative, something different happens. We'll talk about that in just a second. If a is between 0, the absolute value of a is between 0 and 1, the function is compressed. So it is essentially fatter. And then if a is less than 0, whether it's a fraction between 0 and 1 or not, even if it's just -1, it's a reflection across the x-axis, meaning it opens down. Now, B and C ends up being your y-intercept, because if you plug in 0 for x, whoops, that squared should go on the outside, a times 0 squared plus b times 0 plus c, that becomes 0, this becomes 0, so f of 0 will always equal c when you're in standard form. And those are kind of the information you can take directly from the equation. Some other things that are important to be able to find are your vertex. And your vertex, remember, the x value comes from the axis of symmetry. Now, one of the cool things about parabolas is it's symmetric with respect to a line, and it's the vertical line that passes through the vertex. The axis of symmetry is always given by the opposite of b over 2a when in standard form. So that's how you find the x value. And then to find the y value, just plug that in. And the notation that tells us to plug it in is function notation. My parentheses are getting bigger. So f of negative b over 2a just means plug in negative, whatever that value is, and to get the y value. And then for x-intercepts, that's the last thing that we will kind of talk about at this point. We're going to talk about more in the future. We want to set the equation equal to 0 and solve. And in this form, you should be thinking solve using factoring or the quadratic formula. And I want you to practice factoring. Try factoring first. All right, the next form, so there's all of that information. The next form that we're going to talk about is what we call vertex form. This is also sometimes called graphing form. And for this form, it looks like f of x equals a times x minus h squared plus k. In this form, the vertex, so a does all of the same things, which is kind of nice. So everything we talked about before, a still does. The vertex is very easy to see, hence the name vertex form. It is hk. Notice, though, that because this is subtraction right here, whatever number goes right here is kind of the opposite of what you see here. And then to find x-intercepts, you're going to set f of x equal to 0, and then unwrap x using inverse operations. You don't need to expand that binomial. You don't need to do x minus h times x minus h in FOIL. You can just unwrap x in order to find your x-intercepts. And then to find your y-intercept, you set x equal to 0 and solve. And it's not quite as easy as it is in standard form, but you can still pretty easily find it. And then the last form, and this is probably the form that we see the least with quadratics, but it's going to become very important when we get to higher degree polynomials like cubics and quartics and so forth. And it is f of x equals a times, x minus p times x minus q. And this is either intercept or factored form. And just like with vertex form, we call this intercept form because it tells us the x-intercepts. So the x-intercepts, if I set this equal to 0, it's already factored for me. I could divide by a, giving me 0 equals x minus p and x minus q. So x minus p equals 0, x equals p, x minus q equals 0, x equals q. And that happens every single time. So this value right here and this value right here end up being your x-intercepts. And because quadratics are symmetric with respect to a vertical line, we know that halfway in between the x-intercepts is where the vertex will occur. So I need to find halfway in between p and q. So to find halfway in between, add them and divide by 2. Oops, that's not 0. And then to find the y value, plug that back in, whatever that value is. So this looks messy, but it really is just telling you to take your x value, plug it in to find the y value. And then the y-intercept, you, again, just plug in 0 for x and solve. Now the last thing, one thing that I hope for you, let's turn on some graph paper. One thing that I hope for you is that you're able to graph without having to sit and plug points in all the time. Now, sometimes you might need to, sometimes it's actually easier. But something that's good to know is, well, how do you graph this just by hand? So if I take a quadratic, if I just graph f of, let's do this in a different color. Let's say, what color do we want? How about some green? So let's say f of x is just equal to x squared. So if I plug in 0, I get 0. 1 squared is 1. 2 squared is 4. Negative 1 squared is 1. Negative 2 squared is 4. So we know that no matter how far we go over, we are going up that number squared. Now, what gets tricky is we are going to move this around. So I'm going to pick a function just in vertex form. Let's make that a little bit darker. sorry. So f of x equals, let's do negative 1/2 x minus 3 squared minus 1. So the very first thing I would think is, what's my vertex? And my vertex is 3, negative 1. So opposite sign, negative 1. So I'm going to plot that first. And then I'm going to use my a value to go from there. And the reason I stress so much information about the a value when we were talking about standard form is that's what I use to graph. So I know that this function will open down because a is negative. And I know that the compression factor, and I'm going to say the vertical compression factor, is 1/2. So if I go over 1, I typically would go up 1 squared. But now I'm going to go over 1 and I'm going to go down 1 squared because it opens down. But then I need to compress that. So I need to compress it by a factor of 1/2. So if I go over 1, I'm going to go down 1/2 because 1/2 times 1 is 1/2. And then I'm going to make it symmetric. So if I go over 2, I should go up 4. However, I know I'm going to go down, but then I'm going to compress it. So I'm going to multiply it by a factor of 1/2. So if I go over 2, I'm going to go down 2. And I'm going over from the vertex. So if I go over 3, 1, 2, 3, I should go up 9 for the parent function. So instead, I'm going to go down half of 9. So 1, 2, 3, 4.5. So half of 9 is 4.5. And that's a quick way of graphing, and I will show you this multiple times. It's kind of a quick way to be able to sketch a quadratic function. Now, the other option is to make a t-table for the parent function and then talk about transformations. And I will show that in the video on standard form, or excuse me, on vertex form, but we will get to that. I hope that you're having a good day, and I will talk to you soon.